Dear students, let us start our chemistry lesson. First of all, rules of filling atomic orbitals. Okay. There are three rules to fill atomic orbitals. First one is a Aufbau principle. Aufbau is a German word which means increasing order. Okay. This principle says that orbitals are filled in the increasing order of their energy. Orbitals are filled in the increasing order of their energy. That is Aufbau principle. Okay, which means low energy orbital filled first. Then only electron will enter into high energetic orbital. Then how to tell the order of increasing energy of orbitals? Energy of orbital is directly proportional to n plus L. If n plus L is high, energy of orbital is high. If n plus L is less, energy of orbital is less. Okay. You know very well that n is a principal quantum number, L is azimuthal quantum number. For example, energy of 2s orbital, energy of 2p orbital. We have to find out which one is more energetic. Let us find n plus L. 2 plus 0, 2. 2 plus 1, 3. So we get more n plus L for 2p orbital. That's why 2p has greater energy than 2s orbital. So according to Aufbau principle, 2s orbital filled first. Then only electron will enter into 2p orbital. Take another case. Energy of 3p, energy of 4s. Which one is greater? Let us find n plus L. 3 plus 1, 4. 4 plus 0, 4. Both have equal n plus L value. Okay. Then, the orbital having high n value should have greater energy. More the n value, more the energy when n plus L sum is equal. Okay. So, according to Aufbau principle, 3p orbital filled first. Then only electron will enter into 4s orbital. Okay. There is a diagram called Euler's diagram. It is an easy way to tell the increasing order of energy of orbitals. Euler's diagram. Okay, let us draw that Euler's diagram. One S, 2S, 2P, 3S, 3P, 3D, 5S, etc. So we have to draw slanting lines. So the slanting line first enters into 1s orbital. So 1s has the lowest energy, next 2s, next 2p, 3s, 3p, 4s, etc. This is increasing order of energy. Increasing order of energy of orbitals. Okay. So first electron enter into 1s orbital, then into 2s orbital, then into 2p, like that. Okay. And there is another method to explain Aufbau principle. For example, 2s orbital and 2p orbital are there, which has a low energy. 2s has a low energy. Okay, so electron entry into 2s first, then only electron entry into 2p. Okay, this obeys Aufbau principle. I am drawing a configuration like this: 2s1, 2p1, which is completely wrong according to Aufbau principle. Why? Because 2s orbital has low energy and there is an accommodation of one more electron in 2s orbital, but the electron will enter into 2p orbital. So this violates Aufbau principle. This is not according to Aufbau principle. This do not obey Aufbau principle. Why? Because without filling 2s orbital, electron will enter into 2p orbital, which has higher energy. Okay, so this is correct according to Aufbau principle, and this is wrong according to Aufbau principle. Okay. Let us go to the next one. Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. Okay, it is applicable to degenerate orbitals. Applicable to degenerate orbitals. Degenerate orbital means orbital having equal energy. Orbitals with equal energy are called degenerate orbitals. So while filling degenerate orbitals, you have to follow Hund's rule. It says that pairing takes place only after all degenerate orbitals filled with one electron each. While filling degenerate orbitals, pairing of electrons takes place only after all degenerate orbitals filled with one electron each. Okay, let me explain this statement. In 2p subshell, there is 2px, 2py, 2pz. All the three are having same energy, that's why they are degenerate orbitals. While filling these degenerate orbitals, pairing takes place only after all orbitals filled with one electron each. So in 2p, you have to pair the fourth electron with the first one. So this obeys Hund's rule. Obeys Hund's rule. If you draw a configuration like this, here pairing takes place with second electron, not with fourth electron. So this do not obey or violates Hund's rule. So while filling degenerate orbitals, you have to follow Hund's rule. Pairing takes place only after all orbitals filled with one electron. So this is a 2p subshell. There are three orbitals having same energy. So 1, 1, 1 with parallel spins, and pairing takes place with fourth electron. That is Hund's rule. If it is not like that, it violates Hund's rule, which is wrong. So this is correct, this is wrong. And the third and final one is Pauli's exclusion principle. Pauli's exclusion principle. It says that no two electrons can have the same set of all four quantum numbers For example, let us represent 1s2 electronic configuration. 1s2. It should be represented in 1s orbital with opposite spins. Okay. So this follows or obeys Pauli's principle. If the same configuration written like this, this do not obey Pauli's principle. Why? Because in an orbital, the only quantum numbers differs is the spin quantum number. In this configuration, it is plus 1 by 2, then it is minus 1 by 2. In the second one, if it is plus 1 by 2, this is also plus 1 by 2. They have same quantum numbers. These two electrons have same quantum numbers. But according to Pauli's principle, no two electrons can have same quantum numbers. So that's why this kind of representation is not possible. Only this kind of representation is possible. Okay. And one more thing is, an orbital cannot have more than 2 electrons. That is also according to Pauli's principle. In other words, we can say that an orbital can have only 2 electrons with opposite spin. Any orbital can accommodate only 2 electrons, not more than 2 electrons, only 2. There is a maximum chance of 2 electrons in any orbital, and they must have opposite spin. If one is clockwise, other one should be anti-clockwise. Okay. Now these 3 are the rules, and let us do some objective questions. First question: which of the following violates Aufbau, Pauli and Hund's rules? There are 4 configurations will be given to you. You have to find which one violates all the 3 rules. First one, okay, let us check these options. In the first one, this is a 2s orbital, this is a 2p orbital. So Aufbau principle is followed. Why? Because after filling of 2s orbital, electron will enter into 2p. Okay, and the rule violated is Hund's rule. The only rule violated is Hund's. Okay. Next, second one. Here, Aufbau is violated. Why? Because without filling this low energy orbital, electron enter into 2p. So first violates Aufbau. Next, pairing takes place with the second electron, but not with fourth electron. Okay, so this violates Hund's rule. And no two electrons have same quantum numbers. Here both electrons have clockwise spin. So this also violates Pauli's principle. So all the three rules are violated in the second one. So second one is correct. Which of the following violates all the three rules? Is the second one. Okay. Thank you very much.